This is a video on the basics of complex numbers. It explains what complex numbers are and how they work. This understanding is essential to Category 4 in Meat 3. So the most important concept is that I is equal to the square root of -1. And this is the same as I squared is equal to -1. No real number yields -1 when squared because even a negative number has a positive square. So an imaginary number called I was created. So a complex number is of the form a plus bi, where b is just a real number and so is a, and b is multiplying I. So a and b belong to the set of real numbers. So some examples are 0 plus 0i, and that's just 0. But there's also like 1 plus 1i, and even 0 plus 3i. So these are all called complex numbers. Even a number like 3 is also a complex number because b is just 0 and a is 3. So a complex number is any combination of real numbers and power in multiples of imaginary number I. So another important thing is the different powers of I. So let's write those. So I to the 0 power is just 1. Anything to the 0 power is 1. And I to the first power is I. So it's just like that. And also, we just said that I squared is -1. So then I cubed is equal to I squared times I, and that's equal to -1 times I, and that's -I. And I to the 4th power is I squared, and that's -1 squared, which brings you back to 1. So you can kind of see that I to the 0 power, 4th power, and 8th power is just the 4th power squared. So any multiple of 4, if you raise I to that, you get 1. And from this, we see that each of those, if you just multiply by I, again, you get I to the 1, 5, 9, etc. gives you I. And I squared to 6th and to 10th, etc. gives you -1. Because it's like multiplying each of these by I squared. And also I to the 3rd, 7th, 11th is -I. And then if you try to write I to the 4th, 8th, 12th, you see we're back at 1. So we don't need that. So we see this pattern. I to any power by itself can either be 1i, -1, or -I. So let's try to see what I to the 67 is. That's equal to I to the 4th raised to the power 16 times I cubed. And we know each of those I raised to the power 4 is just 1. So they don't matter. And that gives us I to the 67 equals I cubed, and that's also negative I. So we can take large powers of I and turn them into smaller powers of I that based on how many I to the 4s go into it. Okay, so now let's move on to multiplying complex numbers. Let's say you have the complex numbers 2 plus 3i and 1 plus 2i. So again, you just treat I kind of like a variable. So we FOIL and we get 2 plus 4i plus 3i plus 6i squared. And this is 2 plus 7i plus 6 times, whenever we see I squared, we know by definition of I, it's negative 1. And then we write it as negative 4 plus 7i. So that's cool how you just get another complex number of the form a plus bi when you multiply two complex numbers. Now let's look at a special case. Let's try multiplying 2 plus 3i and 2 minus 3i. So FOIL again, and you get 4 minus 6i plus 6i minus 9i squared. And these two cancel out, so you get 4 minus 9 times negative 1, because we see the I squared. And this is equal to 13. And this is cool because you have two complex numbers being multiplied and giving you a real number, which is much simpler than the complex numbers. Okay, so now let's use that idea to divide complex numbers. So let's try that with the numbers 1 plus 2i, and you divide that by 2 plus I. So we know this, we can multiply the numerator and the denominator by a fraction. Or we can do it this way and do 2 minus I over 2 minus I. So this, on the denominator, you get 2 plus I times 2 minus I. And on the numerator, you get 1 plus 2i times 2 minus I. So since we've already seen all the calculations on how to do this, I'm just going to write the result of doing these calculations. So the numerator turns out to be 4 plus 3i, and the denominator turns out to be 5. And so these two complex numbers, interestingly, they give a real number. And this one, you can also, if you want, you can write it as 4/5 plus 3/5 I. And you see that this thing over here is much simpler than what we had initially, because a complex number denominator is kind of hard to work with. So why does it work that whenever you have a number a plus bi and you multiply it by a minus bi, you always get a nice number. So let's FOIL this out. You get a squared minus a times bi, and then you get plus bi times a minus b squared I squared. And this these two terms, again, they cancel out, and you get a squared minus b squared, and I squared is just -1. So you get a squared plus b squared. And since a and b are real numbers, a squared and b squared are also real numbers, so this is a real number, even though the two numbers we multiplied are complex. So this concept of if you have a plus bi, then if you multiply it by a minus bi, you get a real number. It's called complex conjugates. So that's the strategy you can use to make it easy to work with fractions. If you multiply both the numerator and the denominator by the same thing here, because 2 minus I over 2 minus I is just the same thing as 1, so you're just multiplying by 1. And then you get a denominator that's just a real number, so that you can write it as a plus bi again, instead of a plus bi over a different complex number. So I know I didn't talk about the complex plane. I may make a separate video about this in the future. So an overview of what we did was we looked at what I is, and this is the whole point of this video, is that I squared is -1, and then all of this stuff is just playing around with different powers of I and mixing I with real numbers.